All right, so Szymon here is an old friend. He gave talks on he gave talks on every possible event, I think. But he did give talks at local meet.js chapters a lot, and he's one of our favorite battle-tested speakers. And he is the one that's going to pull you in the direction of some JavaScript mobile stuff. And this is going to be the most mobile-related talk of today, as expected. So I'm sure that's why you're here. And I want to stall a little bit more, but this is a very exciting one because an open source tool is getting announced, and I just love these where someone comes with their hard work and spends additional time to just tell people, hey, take this for free. That's the guy. All right, give it up for Szymon.
All right, I can hear myself, so I guess everything is working correctly. So hello, everyone. It's super fun to see so many of you here today. Because I wasn't sure how many people will attend such meet.js summit, because we all know that after COVID, there was this search for public meetups, and then many of them just died naturally. I myself am trying to keep going with my Google developers group in Toruń. Because I'm from Toruń, I basically drove here to Warsaw from Toruń 3 hours across 2 different traffic scenarios with cars, trashing each other. But I'm finally here, and I need to keep up because, well, the time is running out. Okay, so today I will tell you the story of Voltra, of one of the libraries I created this year. Because my day-to-day work is basically creating open source. I'm currently working in Callstack as a React Native expert. And basically, I'm part of something we call internally Callstack Incubator, where we basically play with technology. We are trying to push the boundaries even further. We are trying to break some libraries to fix them, and so on. And during my time in Incubator, I created there are 3 libraries. In reality, we have 4 right now. So the first one is Rozenite. Do we have any people working with React Native? Do you know Rozenite? Rozenite, do you know the first one, the Rozenite? Okay, so if you work with React Native, you can use Rozenite to inject custom plugins into React Native DevTools, something that has been missing from the beginning, I would say, of React Native. Then I created Harness, which is basically a way to run JavaScript tests in full-blown end-to-end React Native environment without any mocking. You have access to all the native APIs. And now we are going to talk about Voltra, which allows you to build live activities, widgets for iOS and Android via React Native and JavaScript. So if you are interested in Voltra, you can always go to use-voltra.dev, where you will find documentation for this library. But here today, I want to briefly show you what Voltra is, what are the capabilities of Voltra, and then we'll go through the process of creating such Voltra from scratch by ourselves. So to start with, how do we install Voltra? If you want to use Voltra, you basically install a package. Then you add a custom Expo plugin to your Expo setup. And then finally, you run Expo prebuild to generate your native code. And then you can start using Voltra, which looks like React Native. And that's pretty much it. You can use JSX. Basically, you can write React code. And we don't see the pointer, so let's say I will try to point you in the right direction. You can just use JSX, plain components from Voltra namespace. You can provide props. You can use the same styles you use for React Native. And for example, if you take this component, delivery status, and you try to run it via Voltra, you will see this live activity running on your iOS device. And the case with widgets is pretty much the same. Again, we have this Voltra namespace with props, but this time we are displaying our widget in the home screen space. For Android, it's a little bit different because we have this Voltra Android namespace. Because Voltra under the hood is using native views for Android and for iOS. So obviously there will be a different set of components for Android and for iOS. And it all looks like some kind of magic. Like I had to do a lot of work in native, in Kotlin, in Swift, maybe in C, Objective-C, if somebody is still working with Objective-C. Then that person will know my pain of, well, having to deal with Objective-C. But in reality, Voltra is basically a clever engineering, a clever combination of existing components plus some custom ones with addition of glue between them to make them work together. So basically, we are going to use React, no surprises here. We are going to write a custom renderer to convert from React, from those nice-looking JSX trees to JSON, and then we will use native frameworks under the hood to show basic views in the native UI. So, like I said before, we are going to build a minimal Voltra implementation, totally from scratch. And because of that, we need to talk about requirements, because we cannot start working on something not knowing what we are going to build. So, to start with, the first requirement is that we are going to work with iOS only, because we have only 20 minutes. And to do so, we need some way to map from JSX, from the components we use in React, to Swift UI, so the framework for creating UIs for iOS. We need to support dynamic island because Apple. Apple is Apple, so if they create something new, they kind of force you into using it. So when you create live activity, you need to provide the UI for dynamic island, and we will also talk about it a little bit later. We cannot force people to rebuild native code, because that's the biggest pain of working with React Native, to constantly rebuild native code. So we want people to know, to be not forced to rebuild, and we want people to not be forced to use any native code, no Swift, no Kotlin, nothing like this. And the last part, we need to support remote updates, because live activities are meant to be like status of delivery, for example. And if you don't know, iOS will suspend your app after around 30 seconds of being in the background, so we can't really use native API to do so. We need to kind of push the updates from the remote server when we have the total control over when exactly the push will happen. So, no surprises. React powers web. Websites, applications. We also use React to power mobile apps. React Native, NativeScript, links from ByteDance. React powers videos. If you don't know, there's Remotion library, which you can use to basically create videos with React, with animations and so on, with code like highlighting. It's a good tool. I encourage you to try it out. We can use React to create presentations, just like this one. It's using React under the hood. And it still works just fine, and it's super easy to be used by React developers. So this idea came to my mind like 2 years ago, I guess. What if we do the same? If you use React to just describe how the native UI is supposed to look like. And we are going to do exactly this. So again, no surprises. I keep my fingers crossed. It's not a surprise for you that when you create your app with React, you just build a tree of components. You start with some root component, then you branch out to some subcomponents, and this hierarchy can go on and on and on and on. And finally, you will have some leaf components, which usually are host components. And those host components are basically, for example, in web, those will be divs, spans, articles, sections, head, body, yada, yada, yada. Those are like the most minimal native views available on a given platform. So basically, React is supposed to get our custom components and strip those components, those hierarchies we build with React, from all the abstractions we create with our custom components. In the end, we can say that React is basically a converter from JSX to some kind of JSON. Of course, it's not that simple in reality, but for this purpose, for this presentation, let's say it's basically a converter. And then there's the second part called rendering, when we take something like React DOM to convert this JSON description of our UI to a real, in this case, HTML syntax, so our browser can display it in practice. And with Voltra, we want to do the same. We want to create this description, like JSON-like description, and then pass it to native, to iOS and to Android, to turn into native views. And we will do so with something called React Reconciler, which is something not many people know about. And this is basically a way to build your custom renderers. So you want to, I don't know, support some new, it's hard to come up with an idea, like on the spot, some new platform, let's say. So you'll get this React Reconciler. You need to provide some host config, which is basically telling React how to create instances of components, how to append children, for example. And then you use React Reconciler to create a root. And then inside this root, you can schedule updates. And that's pretty much it. Starting from this point, all the hooks are working just fine. Concurrent mode in React is supported. You get suspense and all React libraries. So this is a perfect opportunity for us when creating Voltra to reuse this reconciler. And then when we have this JSON description, which we created via reconciler, we can play with native side. So for example, in SwiftUI, the code look like this. You create a struct of type view with body, and in body, you just use some other components. So for example, for this case, it will be text, of course, the type is text, with some value called hello world. So we need to kind of do the same for, well, many components. All the components we want to support. In the end, we will end up with this big switch case, which is not really a code smell. It's like, you need to do this one way or another. And in the end, with all this in place, with this render, with React Reconciler, with those views we created before, with the switch case, you will technically get something like this. So we displayed something. But this is just the beginning of our journey. Because then, we realized that we need to style both text and the container. And Voltra tries to mimic React Native. Tries to. It's not compatible. Like, SwiftUI uses modifiers. React Native uses style sheets. There's no margin in SwiftUI. Like, it doesn't exist. So how we create margin in SwiftUI? Well, it turns out that if we apply padding in correct order 2 times, the first padding will, and for some reason, the contrast is too big, but you need to kind of trust me that you should now see like this rectangle around Voltra of 60 padding. So basically, Voltra, the text will be inside the box, which has this 16 pixels of padding. Then if we apply background color, we will see the padding, the colored padding. And now in web, you would assume that if we apply the padding again, the internal padding we added before will be overwritten, for example. So the box will be larger, the color will be, well, the colored box will be larger. Not really. Because in SwiftUI, padding is basically filling the current bounding box of an element. And then when we apply the second padding, we're basically recreating margin from scratch. So that's something that Voltra is trying to do, constantly trying to mimic what we have in React Native, but with, for example, SwiftUI or Jetpack Compose primitives. But we don't need only a single variant. We need a couple of them. Because like I said before, when it comes to live activities, I quickly realized that Apple is forcing me to not only provide lock screen variant, this default one you see on your lock screen, but also dynamic island, like 2 variants, the left variant for compact, the right variant for compact, the minimal variant, so this like only the circle on the right side. And I also need to provide a variant for the expanded state, where when I click on a dynamic island and the space enlarges. So this is another variant we need to provide. So if we have something like this, start live activity with our JSX tree, it works just fine. So like naturally, we want to make it more versatile. We'll create an object, we'll add properties for lock screen, island, and all the variants. It should work, right? Like, this is simple, it should work. But the problem is that technically a simple change can have unforeseen consequences. And in this case, when I was working on the initial version of Voltra, I realized this is not going to work. Because there is something that Apple doesn't really tell you like directly in the documentation. So live activities must fit in 4 kilobytes of data. Like the amount of data you can pass to the live activity is basically 4 kilobytes. So to compare it with like some day-to-day work, let's say, average photo is over 2,000 kilobytes. MP3 song is about 4,000 kilobytes. We have only 4. 6 variants. So yeah, we need to start crunching. We need to find a way to make our payloads, our description of the UI smaller. And the first idea that probably came to your mind right now is basically to use some kind of compression. So we have Broadly compression, gzip compression. So let's use it. OK. We will get 70% of savings, but then we will lose another 30% because we need to serialize it into a string, and we use base64 compression serialization. But in the end, we will get 40% of gains, which is good, but it's not good enough. So then we can play with dictionaries. So for example, instead of providing type, we can provide T. And instead of Voltra text string, we can provide 1, which internally will be converted into Voltra text. And the same applies to the props, font size, for example, C, font weight, W, children, C, and so on, and so on, and so on. We will gain another, let's say, 30% of gains. But again, this is not enough. So then we can try to deduplicate styles. So we know that there are cases when we create styles once and then reuse them across the app for many elements. And by default, we would send this style sheet many times in the JSON, which is like total waste of space. So while we render, we can check whether we stumbled upon this particular style sheet before, and if so, we can basically embed it once in the registry called R in this JSON, and then just provide a number which the renderer on the native side will understand as a reference. And the same approach can be done to the whole elements. Because, for example, if we have something like GitHub activity chart, you know those rectangles, like 60 rectangles in 4 lines saying how many commits you did during, I think, a week, if I'm not mistaken. So basically, when I was working on Voltra, I published some internal preview version for people working at Callstack to test it out before it's public. So one of the guys thought about creating such graph on the live activity. So I am somebody on GitHub with GitHub logo, and I want to have my activity graph shown on my live activity, basically. So the initial version of Voltra was able to show only 1 row, 4 kilobytes of data. Each element is a distinct element with distinct props. But in reality, if you look closely, you will see only like 4 variants of them. And with this deduplication I just described, we were able to push the limits like there was no enough space for the rows. So this fixed the problem again. Something simple, but with like proper engineering can be done easily and provide value. And then we need to move to push-based updates, push-based push notifications that are going to update our live activities. So the course of action is pretty simple. We push JSON. Again, we use this JSON on the device. So live activities are meant to be rendered in the background. This is something that the operating system will do for us. With the JSON, we pass via live notifications, and then we'll get live updates without rebuilding, without any local API calls. But there's a problem. And this was the moment when I realized I did a huge mistake. Because I realized that in server-side rendering, and this is what we are going to do, we don't need hooks. We don't want to have hooks executed because somebody may create use effect reaching to some globals which are not present. We don't need concurrency, no async-awaiting components. We don't need like persisting the state and synchronizing the state between JSON, between JavaScript and native because we do a single pass and send the JSON. And the problem is that React Reconciler cannot be used this way. You cannot really turn off hooks in React Reconciler. Crap. So I need to do something about this. So what people do? People look into existing solutions. So I dive into the code of React DOM and realized they are not using a reconciler, like this React Reconciler. They are building their separate renderer with JavaScript, like no dependencies. They're just walking the tree of React. So I did basically the same thing. I created a traverse function, and I'm going to call this recursively for each node I stumble upon. So if it's string, it's basically a text element. If it's array, I need to traverse into all the children. If it's element, React element, I need to call the function to render it if it's a function component. So basically, it looks somehow like this. So we start with the app. We go into the first view. So we start creating the view, but we first need to go to the children. So we start with text. Then the renderer sees the hello string, which is a primitive, which is considered a host component. So we will just print hello. We will go back to the previous text component, go back to the view, go down to the user because that's the second children. That's the function component, so we will execute it. We will see new children, and again the same approach continues for children of user. And if there are many custom components included, function components, this will continue down to the leaves. So we don't need hooks. We don't need use effects. But there's a case where we need hooks. So for example, we want to have use context because usually we use this to inject some themes, some colors to all the components. So Voltra needs that to be able to basically have the live activities themed. So yeah, we will create hooks from scratch, which is fun because it's super easy, despite being like scary at the first glance. So we need a dispatcher, something like an object which will contain all the hooks, all the implementations, which React will call internally when hooks are executed. So we will create use context, which will read from the context registry. We'll go into context registry in a minute. For state reducer, we don't need any like state changes because it's one go, no state. So we'll basically return nothing or the internal or the initial value. Memoization doesn't really work because we don't need it. So we will just return whatever is passed in. And the same goes for effects. We don't need effects, so we will basically have them do nothing. So how hooks work? I didn't know. So what I had to do, I had to dive into React itself. So there is this funny named property in React, which is exported. Do not use or you will be fired. But I did. I had to. And there, if you go into this and you console log it, you will see there's age property. And this age property contains something called dispatcher. And dispatcher is basically this object we just saw. Object with all the hooks, all the implementations of them. So basically, I override this age property. I call the function. React internally will see use effect. We'll look up the current dispatcher. We'll see our dispatcher. We'll call our use effect. And then after the work, we revert the change so React Native can see its own dispatch in this place. And for context, it's basically a matter of going down the tree. If you stumble upon a context provider, you put it in a map with the context reference itself. If you need to read it, you basically read the map. If you go up, so you are exiting the context provider, you just remove the context from the map, and it just works. So Voltra is not only about hooks, not only about styles. There are many problems Voltra tries and succeeds in doing. So, for example, remote images, which are like not supported in live activities, but Voltra can emulate them. For example, we have flex layouts right now, so you can use React Native flex properties to style your live activities, and of course, the live updates, changing the code changing the UI as we write code in development. So what's next for Voltra? Cross-platform unification, so maybe trying to give some like shared components for both Android and iOS, so you don't need to implement your live activities and widgets twice. And maybe, just maybe, Voltra will be able to provide you a way to build Apple Watch applications. I internally had this POC ready like 2 months ago, which allowed me to use Voltra to render Apple Watch UI and basically handle interactions and so on. So this is Voltra. You can go to usevoltra.dev to learn more about the library itself, how to use it, and so on. There is this QR code which will lead you to this website. If you want to know more about what I do in my day-to-day work, about my new libraries, about the problems I stumble upon, you can observe me on X, where I try to push as many updates as possible. And that's pretty much it. Thank you.
Let's unplug and go have a chat.
Close it?
Yeah, I'll just unplug and let's go have a chat.
Yeah.
All right. So I'll hide that for you for now.
Nobody's going to steal it. Don't worry.
I mean, I already did. So yes, no one else is. So I guess the top question is about the support for multiple OS versions and how they differ. You partially answered it in next steps, so I suppose it's not complete yet. But can you talk a bit about that?
Like, there are certain features of Voltra which cannot be used in, for example, iOS 16.2. Like, for example, if you want to start live activity from a remote service, because you can do so. You can send a push notification to start the live activity from scratch. You can do so, but only in iOS 17 or 17-2, whatever. So basically, if you try to use it, this functionality in Voltra running on a device with iOS 16, nothing will happen. Like, it will be silently ignored. The same applies to, for example, glass morphism. So Voltra supports glass morphism. You can use glass effects, this liquid glass stuff.
Yep.
But in iOS 16, there will be nothing. Like, basically, and in 17 you will see like transparent background, and that's pretty much it. But you can always provide some background fallback for this case. So there will be some background at least.
All right. So it gives you reasonable defaults, and then you have to build on top of that.
It's basically opt-in behavior for new features. And when it comes to like trying to synchronize, let's say, Android with iOS, it's not that simple because, for example, Android is super limited when it comes to layouting. I cannot do like no dynamic stuff in there. So I doubt I will be able to like provide a one-to-one implementation of, for example, Flexbox on Android.
Oh yeah. Flexbox is difficult. All right. And what challenges and pitfalls arise from supporting adapters for both platforms? What's painful for you?
Oh, I would say Android is painful. Like, really, because they created widgets like, I would say, 10 years ago. Like, I think Android 5 or 4 had widgets inside. So they came up with a solution that they will basically have XML, which will describe the views. And we are stuck with it even today. Like, there is no dynamic creation of... Technically, there is some some possibilities to create those dynamic views, because that's how they name those XML documents, with APIs like imperative APIs, but you cannot do everything with those imperative APIs. So it's like, oh, it's possible to do in native widgets, but you cannot create this widget in the code from scratch because because they don't provide API for that.
Okay.
So
Well,
this is painful, to be honest. Like one example, charts. In Swift UI, we have Swift charts. Just like that, they work. In Android, there are no charts. You can create a bitmap, render chart into a bitmap, and try to pass this bitmap to widget just to show the bitmap as an image, to have this chart in place.
see, contribution idea, everyone.
Yeah,
Build it. Or tell AI to build it.
There are many problems like this.
All right, thanks. There's a lot more questions and not a lot more time. So
I know. I was 25 minutes, so we had 3 minutes.
Yeah.
I was observing the
I will send everyone downstairs later. So now you have to go there as well. Try to find Szymon with all of your remaining questions. And thank you. This was very technical.
It was very fast. To be honest, 20 minutes, it's not enough.
Thanks. All right.